So under loan repayment or under loan amortization, the first thing is that you must have the sum borrowed. So we can call it X. We can say let the sum borrowed, let X be the sum borrowed today. Let X be the sum borrowed today. And today means at the beginning. So it is the same as saying at year 0 or at the beginning. Then after borrowing, there must be the rate of interest. So the rate of interest, we can say let R be the rate of interest. Let R be the rate of interest and let N be the period of the loan. Then another thing which is important is that we have to know the terms of the interest. What are the terms of interest? When we say the terms of interest, the terms of the interest can either be annually, which means the interest is charged on a single year, or it can be semi-annually, twice in a year. It can be quarterly. It can be quarterly, or it can be monthly, depending with how the question is presented. So the issue is always what is the periodic installment. What we need to establish is the periodic installment to be paid. Periodic installment. So this periodic installment on the loan is what we need to establish. We can either compute it manually, or we can use the payment function known as the PMT in Excel. The PMT in Excel is the payment function that we can use to get the periodic installment. And this periodic installment, we can call this periodic installment A. This is our unknown. And this installment is made up of both the principal amount together with the interest. This periodic installment is made up of the principal amount together with interest. So when we are doing this in class, in our financial management class, we say that if you want to get this periodic installment A, then it is given by the sum borrowed we divide by the present value interest annuity factor, N R%. This is what we said, but this is where the interest is being paid. The terms of the loan is annually, or interest is annual. The terms of the loan is annually. But if the term of the loan is semi-annually, then we have the sum borrowed, X, we divide by the present value interest annuity factor. This time round we have 2N R% divided by 2. And in this case, the term of the loan is semi-annually. In the same case, it is also possible to get the periodic installment where the term of the loan is quarterly. Present value interest annuity factor 4N R% divided by 4, where the term of the loan is quarterly. So that is what we were saying, and this is how we've been computing it inside in class. After getting the periodic installment, you can be able to prepare the loan amortization schedule and show how this loan will be repaid. So if you want to prepare the loan amortization schedule, then in most cases we assume the use of reducing balance, so that the loan structure should look like this. We'll have the period, we'll have the periodic installment which we'll have computed. Then from this periodic installment, and this periodic installment will be constant all the way through, it will be the same from one period to the other. Then from the periodic installment, we have the interest, we have the principal amount, and finally we have the loan balance. And our loan amortization schedule must always start from period 0 all the way up to period n, depending with the number of periods that we have. And this periodic at period 0 will only have the original sum borrowed. At period 0 we'll only have the original sum borrowed. So our periodic installment must start from period 1 all the way downwards. And our loan repayment should be on reducing balance such that the loan balance at the end of the year or at the end of the period should be exactly 0. So this is the general structure of how a loan repayment schedule should look like. So based on this understanding, and this is what we've been doing in class for a long. The reason why I always take you back to class so that we recap this is so that you appreciate that nothing has changed much. And whatever we were doing in class, we are just trying to now apply Excel and see whether we can compute it inside Excel. And that is the whole idea of this course, Business Data Analytics. To make it more practical, we try to do what we've been doing in class inside an Excel environment so that you also familiarize with these functions that exist inside Excel. So with this background, let's have some illustration in Excel and try to apply what we've just mentioned right now. So let's go to our Excel and have a quick illustration on loan amortization. So under loan amortization, let's assume that there is someone who borrowed money. So let's say this is sum borrowed, which we called X. Let's say that there was a sum borrowed of, let's use the 2 million because 2 million, say there's a sum borrowed of 2 million. And of this sum borrowed of 2 million, of this sum borrowed of 2 million, let's have an interest rate. Let's say the rate of paying interest is 10%. Let's say the rate of paying interest is 10%. And the term of the loan, let's have the term of the loan to be 4 years. So if you have the term of the loan to be 4 years, what you need to get is the periodic installment. How much this person should pay? Periodic installment. So if you want to get the periodic installment on the loan, we can get this periodic installment. Let's start by computing it manually and taking the present sum borrowed, we divide by the present value interest annuity factor for 4 years using a rate of 10%. So there are two ways you can go about this. The first way is that we already know the sum borrowed, which is 2 million. So what we need is the present value interest annuity factor for how many years? For 4 years using a rate of 10%. And I already show you how we can compute this using the present value function. So that will say equals to, we need to get the value of a shilling. Already we know it is 3.711, but let me just compute that again. We go to our present value function. The rate is 10%. The period is for 4 years because it's from year 1 up to year 4. And our periodic, the payment in each period this time around, it's 1 shilling because we are looking for the value of a shilling. That's why I'm not taking the actual cash flow. And I say -1, then I say okay, I get rid of the percentage, then I increase the decimal places. So this is the present value interest annuity factor, the one we were talking about previously. This present value interest annuity factor NR%, that is exactly what we've computed. That is what we've gotten to be 3.19. So after getting that, so if you want to get the periodic installment, we just divide and say 2 million divide by the present value interest annuity factor and get. So our periodic installment in this case is 630,961.61. That is how we compute it manually. In case you want to have this separately, you can actually have it as part of your workings. The alternative method will be this. You just say 2 million, you divide by. I can actually insert that present value, the present value interest annuity factor for 4 years using 10%. I can have it as part of my formula. I just reference the 2 million, divide by, then I activate the present value function. I divide by PV open bracket. Then once I open bracket, now the function is active. Then I just click on FX. When I click on FX, I'm at the present value function. I just have 10% for 4 years for a value of a shilling of -1 for 4 years. And you can see that I already have a sub result of 3.169, this one. I already have the sub result. I already have the sub result. I already have the sub result of 3.16, which is now the value of a shilling. And I have the periodic payment of 630. So you can clearly see that from this, I already have my two solutions. So this is also another alternative way of going about it. Then we just say okay, and our answers will still be the same. If you wish, you can just decrease the decimal places. There is no problem. But I've done this manually. I've not used an existing function. So under loan repayment, there is an existing function in Excel that we can use to compute this loan repayment. And this existing function, if you go to formulas under financials, we have the PMT function. The PMT function. And you can see that this PMT function, even if I click on it, it calculates the payment for loan based on constant payments and constant interest rate. We have a constant interest rate of 10%. And this periodic installment is what we are looking for. What is a constant payment for this loan? And that is what we are looking for. So if you want to get the constant payment, you actually use the PMT function. So we want to use this PMT function and try to see whether we can use a PMT function without having to calculate it manually. So let's get the periodic installment using the PMT function, which is the loan repayment function. So if I use the PMT function, then this is how our result should be. We'll say equals PMT. Then we activate the function argument and open our window. We know the rate is 10%. Let me say something which is very important. In this case, I've assumed the terms of the loan is annually. If the terms of the loan was semi-annually, then I could have divided this rate by 2 to make it 5%. But because it is annually, that is why, because it is annually, that is why I've not divided it by 2. Then we have the number of payment periods. In this case, we know the terms of the loan is 4 years. In case it was semi-annually, we could have multiplied these 4 years by 2. So I could have just said times 2 and have it as 8 periods. But because it is annually, we just leave it as 4 periods. Then our present value is the present sum borrowed. This investor borrowed 2 million. To avoid having it as a negative, we'll say minus 2 million. And once we've done that, you can clearly see that our payment is still the same as 630. Our type, in this case, we don't need to fill the type because it's a periodic payment, so there is no problem. Then we just say okay. And using our PMT function, we'll still arrive at the same result. So you can either compute it manually or you can use the PMT function. The August 2024 exam. So in August 2024, we had a question 22. So in the question, we are given a loan amount of 2 million. And then the period of payment we had in years of 5 years. And the repayment frequency is monthly. So if the frequency is monthly, then it means that within an year, it will be paid 12 times. The annual interest rate is 11%. And the monthly repayment is 43,485. So the first part of the question we were told is that use appropriate Excel function to confirm to Mkenya that indeed the monthly repayment amount given is correct. So the question wants us to use an Excel function to verify whether this monthly repayment of 43,853 is correct. So in short, the question wants us to recompute this. So for us to answer this question, this will be part A of our question. For us to answer this question, we just need to use the PMT function to confirm whether this computation is correct. So that we'll say equals PMT, because we know that PMT, what does PMT do? It calculates the payment of a loan based on a constant payment and a constant interest rate. So we can actually use the PMT function, which is a payment function in Excel, to try and verify this. So I'll click on the PMT function and activate it. Then I can open the function argument window. The first item in our argument, we have the rate. So if you look at our question, we have an annual interest rate of 11%. So because we have an annual interest rate of 11%, but remember, this 11% is per annum. but we know that the frequency of payment is monthly. So in this case, I'll divide by 12, and you can see that I'm actually referencing the cell that has 11% and 12. I'm not typing manually, and the reason for this, I think I've already emphasized in our previous classes that when you reference a value, sometimes it becomes very difficult, especially in a scenario where the data is expected to change. But when you reference a cell, it becomes very easy. It makes your data set to be very, very dynamic. Then in this case, the next part is we have the total number of payments of the loan. Because we know the period is 5 years, so we'll click on 5 years, but because it's monthly, we'll multiply the 5 years by 12 months, so that the total periods will be 60 periods. The present value in this case is the total amount which is borrowed today, and the present sum borrowed is 2 million. But because of what we said about financial functions, we have to present that cash flow as a negative cash flow. So that if we present it as a negative cash flow, now we already have our, in this case, we can ignore the future value and the data type, the type, because this is a periodic payment which is being made monthly. So it is neither at the beginning nor at the end. So after getting this, then we just say okay, and you can clearly see that even before we say okay, you can clearly see that even before we say okay, you can see that this our value is exactly what we want. So it is already what we want. So that we just say okay, and we can get rid of the dollar sign, so that using the payment function, the loan monthly repayment is 43,484.85, which is exactly what was there. So we can confirm that the monthly repayment to Kenya is actually correct. So that is that we are saying based on the payment function, the monthly repayment by Kenya is accurate. That is the first part of our question. Then the next part, we are told to prepare a monthly loan amortization schedule for the above loan or motivate. I don't know why the name keeps on changing, but don't worry. Let's just focus on the material part of the question. Prepare a loan amortization schedule to see how the loan clears at the end of time. Have a column for period, monthly repayment, principal, interest, and loan balance. So for us to prepare the loan amortization structure, we are allowed to introduce a column for period. Then we can also have the column for periodic installment. Then we also have a column for the interest. Other than interest, we have a column for loan balance. Not loan balance, but we can have the principal amount. Then finally, we can have the loan balance. Then we can start our period from period 0, but because these are monthly repayment, we expect to have 16 periods. So we'll have 0, 1 all the way up to not 16, but I mean 60. The reason we are saying 60 is because we had 5 years and it's a monthly repayment. So 5 times the 12 is actually 60. So instead of writing 1 up to 60, we can always use the series option. So we just click on our most recent. In this case, I'll just click on where we have 1. Then I go to editing. Under editing, I'll go to series. Then I'm filling the series in this time round, I'm filling it in the column. So I'll switch to column. Column is the one moving from up to down. And the data type is linear. So I want a step value of 1 so that I move from 1, 2, 3, 4 all the way. So the step value is 1. And I want it to stop at 60. So I can just say stop value is 60. When I say, if I said step value is 2, then it could have moved from 1, then it goes to 3, it goes to 5. That could have been the case. But when my step value is 1, it only moves 1 step. So that in this case, if I set the stop value to 60, then it should move from 1 up to 60. And I just say okay. And you can see that we have 1 up to 60. But if you wish, you can still use, there's always the shortcut for everything. You can still drag, then you use the fill option. Still, there is no problem, whichever works for you. Then the next part we have is the periodic installment. Let me make these ones to be bold. We have the periodic installment. Bold, you can always use the shortcut Control B instead of clicking all that. You can just say Control B to make that bold. So at year 0, we should only have the loan, and we already know that the loan that was borrowed was a loan of how much? This was a 2 million. It was a 2 million loan. So this is the loan that was borrowed. So that at year 0, we should not have any periodic installment, neither should we have the interest of the principal. We already know the periodic installment we've computed is to be 43,484.85, and this periodic installment will be all the same up to period 60. So you can just reference this periodic installment and say equals to that. But because I want the same periodic installment to run all the way through, it is the same amount from period 1 up to 60. This is what I can do. Remember, I'm trying to make my data to be dynamic. So what I can do, I can make these to be an absolute reference by highlighting the range. In this case, my cell is B23. Then I just click on the $ F4. After clicking on the $ F4, then I can just now use the fill series. So that when I use the fill series, now I'm able to fill the entire, and you can see that I've filled this entire row with the same value. So I've filled it with the same value, so that if it was to change above, it will equally change from period 1 up to period 60, because I've made this to be an absolute reference. So once I have the periodic installment, the next thing that we need is the interest, the principal, and the loan balance. Remember what we said. I don't expect you to do this manually from period 1 up to period 60. From our knowledge of Excel and relative and absolute referencing, we should only be able to do one computation. Then we use the fill option and allow Excel to do the rest for us. So I can only to compute for one line item. Once I've done for the one line item, then I'll just use the fill option or the drag option that is able to fill the rest. So let's start with the first part. Now we need the interest. We know the rate of paying interest is 11% per annum, but we know that the repayment is monthly. So that if you want to get this interest, then it means that the interest is charged on the amount borrowed, which is 2 million. And this 2 million, now we are charging the interest rate. So we multiply these 2 million, multiply these 2 million with 11%. But because it is 11% per annum, we want to divide these by, let me reference the actual rate. This is the rate, 11% per annum. Then we divide these by 12, so that when I say 11% divide by 12, now I'm getting the monthly interest rate, then close the bracket. That will now give me the interest rate on a monthly basis, and we can decrease the decimal places so that a bit, so that in this case the interest in that month will be 18,311. Then the periodic installment is made up of both the interest and the principal. So if I want to get the principal, then I'll just say I'll take the periodic installment, I minus the interest, so that will give me the principal amount of 25,155. And if I want to get the loan balance, I'll just take, because we are using reducing balance, we'll take the 2 million, we minus the principal amount paid, which is 25. So once we've done this, using relative referencing, we should be able to now fill for the rest. But now there is one last adjustment we need to make. While I was getting the reference, I referenced these 11% and 12 to represent the period. If I don't make 11% and 12 an absolute reference, then it will not be possible to use the field series, because it may give us, or it will give us, a misleading result. So for me to use that fill option, I first of all need to lock. In this case, my 11% is in C5. So I'll just highlight C5 and press F4 to make it that absolute reference. And I do the same for the 12 months is in D4. I lock it with F4 to make it an absolute reference. Once I make it an absolute reference, now everything else remaining, I want everything else remaining to be on relative reference. Once we've ascertained that, now we just use the fill option. And when we use the fill option, we just double click. And when you go to our period 0, you can actually see that it has actually filled everything up to period 60. At the click of a button, we've gotten the answer. And how sure are we that this is true? We are sure that this is true because if you look at our loan balance, at year 0, you can, sorry, not at period 0, but at period 60, the loan balance, you can actually see that it is 0. And this is the clearest test that this computation is actually accurate. But you can still do several checks just to be sure. You can always double click and see whether it has computed what we want it to compute. And you can see even through random inspection, you can see that our data is very consistent. And that is the beauty of referencing. Through a click of a button, you're able to answer the entire question once, and this one should take you less than 5 minutes, so long as you know how to use both relative and absolute referencing. But remember that if someone had forgot to make this an absolute reference, then it will give very misleading results. Let me just show you the consequence of not making these two absolute references. If someone had not made these two absolute references, then it will definitely give misleading results. So that if I was to now use the same, this time around you can see that it is giving me errors. And the reason for that is because now if you double click, if you click on this, it is moving one cell down, one cell down, one cell down. So that this is the cause of this error, because I don't want it to move one cell down every time I drag the formula. So to avoid this, that is why we had to use the absolute reference. And if we go back and just make this an absolute reference C4, remember we said you can make an absolute reference either by renaming or by inserting $sign. But if you have to use $sign, please note that you highlight the cell reference, then you just press F4 once. Because if you press it more than once, sometimes it moves the range that whose reference you want to make absolute. So with this adjustment, you just do that, then you double click, and that's it. So just at the click of a button, you're able to prepare that loan repayment structure. That is how easy it is once you know how to use relative and absolute referencing. And that is how you answer part B of the question. So part C, we are told that as a customer-centric SACCO members are allowed to vary their loan terms to their preference as long as it aligns to loan terms. Help Manoti Were to fill the below table with the correct repayment period and the loan amount in column C and D respectively. That allows him to make a monthly repayment amount of 35,000 and not 43. So there's someone here who only is able to pay 35,000 on the loan instead of the 43,485 that has been prescribed. So we are trying to establish if he decides to pay 35,000, for how long will that loan be paid? And if he decides to still pay 35,000, then how much does he qualify for? So for us to do this, we can use a tool which is known as the goal seek tool. And if you want to get the goal seek tool, if you go to data under what if analysis, we have what is known as the goal seek. So the goal seek tool is a good tool for sensitivity analysis since it allows us to find the right input for any value that we want. But in this case, we want a value of 35,000 because that is what this person is able to pay. So for us to use the goal seek tool, first of all, we have to insert our formula for PMT. We already established that the loan repayment or the loan that the person was able to pay was 484.85. But we can still do the computation afresh. There is no problem because we know that the terms in this case, the duration for the loan, we know that it's 60 months. So that the reason why we are saying 60 months is because it was 5 years. And if the term is 5 years and it is being paid monthly, then it means that it is 5 times 12, which gave us 60 months. So first things first, let's compute we've already done the computation, but I want just to compute it here again based on months so that I show you how we use the goal seek tool. Because we want our answer to be independent. Because this is part C of the question, it has to be separate from what we did previously. So there is no harm, we can still just do a quick computation of that by saying PMT. The rate we know is 11% per annum, but because it is monthly, we divide by 12 so that it is 0.00916666667 per month. The number of payment periods in months, we know it is 60 months, which was, we said it's 5 times. We said it is 5 times 12. And the present value, which is the original loan that was borrowed, is 2 million. So that the current PMT based on the proposal is 43,484. So, but this person is not able to pay 43,484.85. Is only able to pay 35,000. So where we've done our computation using the formula, the goal is to make these monthly repayment to be 35,000 as opposed to 43,484. So first things first is that for you to use this goal-seek tool, you must be in the cell that has the formula. You must be in the cell that has the formula. And already we know that this is the cell that has our PMT function. And we've referenced also all the cells that we want to change. So once I'm in the cell that has the formula, I'll go to data, what if analysis, and I click goal-seek. So the set cell is the cell that has the formula, which in this case is my C21. And I want to change this C21 to a value, and this value is 35,000, because this is what the person is comfortable paying. And I want to set it by changing which cell. So the first item I wish to change, is the one that has, first item that I wish to change is the one that has the periodic payment. So if he decides to pay 35, how much will be the, so how long will be the duration in terms of months? So I'll go and click on by changing the cell that has months, so that is the cell that I want to change. And I want to establish that if the monthly payment is set or is changed to 35,000, how long in months will it take this person to repay this loan, assuming everything else remaining constant? So I'll just say okay. And you can see that if it is set to 35,000, then you'll see that the person is only able to pay, the duration of the loan increases to 81.3091 months. So that is what happens when he decides to pay monthly 35,000 and he still wants to borrow the 2 million at 11%. Then it means that this money will be paid for a duration of 81.30 months. That is that. But in the same case, we can also try to ascertain whether if he still maintains a monthly payment of, let me make this, instead of computing this again, I can decide to, let me see if this will work. Let me see. Okay, I can just do the same computation again. Let's have, the whole idea of goal-seek is that you can only change one particular variable at a time. So I'm also trying to establish what if he wants to maintain the same 60 months. And this time round, he wants to adjust the loan amount at the same 11%. What is the possible loan that he can qualify for, given the fact that he still wants to make a repayment of 35%. So for us to do that, we can have the question as it was. Let's retreat to the original and say that the original sum it's still 2 million. And if it is 2 million, I can use relative referencing and I go back to the original. And I hope you understand how I've switched here to this, because I reference these cells. So when I use relative referencing, it references the same values. So this time round, he still wants to maintain a monthly repayment of 35 million. Sorry, not 35 million, but 35,000. But he wants to maintain the same duration of 60 months at 11%. So how much should the loan be? So for us to do that, we'll still go to our data. We go to what if analysis under goal seek, and our set value, which is 43, we want to change it to 35,000. By changing which cell? This time around, we want to change the cell that has 2 million. So we click on the cell that has 2 million. Then we say, okay. And you can see that this time round, if this person wants to pay 35,000 monthly and maintain the duration to 60 months at 11%, then the loan borrowed will have to be reduced from 2 million to 1.6 million. And that is how we can use the goal seek. We've maintained a monthly repayment of 35,000. So he has two options. If he wants to maintain 35,000, assuming the interest rate does not change, then he can either borrow 2 million and pay it for 81 months, or he can reduce the amount from 2 million to 1.6 and still pay it within 60 months. So this is how we use the goal seek tool to try and change or set a particular cell to a value that we want. So this was a question in the last sittings exam, and that is how you go about it.